Imagine standing on the surface of Earth, gazing out into the vastness of space, and wondering, what if there's something out there that we haven't yet discovered? A massive, mysterious world just waiting to be found? That thought has crossed the minds of astronomers and space enthusiasts alike for years now, and recent breakthroughs suggest that this question might not be as far-fetched as it sounds. Deep within the farthest reaches of our solar system, beyond the orbit of Neptune and the icy realms of the Kuiper Belt, there could be an undiscovered planet, an enigma known as Planet 9. For years, the evidence has been stacking up, but the search for this elusive world is far from over. And while we haven't yet confirmed its existence, every new discovery brings us closer to solving one of the greatest mysteries of our cosmic neighborhood. The idea of a hidden planet in our solar system might seem like something straight out of science fiction, but it's grounded in real, compelling science. For decades, astronomers have been scrutinizing the farthest reaches of our solar system, searching for clues to the formation and behavior of celestial bodies that dwell in the shadows of our distant planets. The key to unlocking the mystery of Planet 9 lies in something called the Kuiper Belt, a vast, icy region located just beyond the orbit of Neptune. This zone, which is populated by icy bodies, dwarf planets, and comets, has long been a subject of interest for astronomers. But in recent years, it has gained even more attention because of something peculiar, strange anomalies in the orbits of certain objects that seem to point to the existence of a massive, unseen world lurking far beyond. The journey to discovering Planet 9 began long before anyone even thought about searching for it. It all started in 1950 with the work of Dutch astronomer Jan Hendrik Oort, who proposed the existence of a vast cloud of icy bodies far beyond Pluto. This region, which would later become known as Oort's cloud, was believed to be the source of long-period comets, those icy visitors that make infrequent trips into the inner solar system. However, Oort's cloud, though a useful concept in explaining the orbits of these comets, was a rather vague and poorly defined region. It wasn't until the early 1990s that a more concrete structure was identified beyond Neptune, the Kuiper Belt. This ring-shaped region of icy debris was initially theorized to be home to small objects like comets, frozen chunks, and possibly even small planets. But as astronomers began to look more closely at the objects populating the Kuiper Belt, they realized something odd was happening. There were strange, unexplained movements in the orbits of certain distant objects, and this piqued the curiosity of researchers. It seemed as though the gravitational influence of an unseen force was altering the orbits of these bodies in a way that couldn't be explained by the known planets of the solar system. Some objects in the Kuiper Belt, like Sedna, were following extremely elliptical orbits, stretching far out into the solar system and taking them to distances that no current planet could explain. Something massive, perhaps a large planet, seemed to be exerting an influence on these objects. The theory of Planet 9 gained serious traction in 2016 when astronomers Michael Brown and Konstantin Batygin, both from Caltech, made a groundbreaking discovery. Brown, already known for his role in the demotion of Pluto from planet status, had been studying distant objects in the Kuiper Belt for years. His work on objects like Eris, Haumea, and Makemake had already expanded our understanding of the outer solar system. But in 2016, Brown and Batygin noticed something even more intriguing. 6 distant objects in the Kuiper Belt were following very peculiar, highly elliptical orbits. What was odd about these orbits was that they were aligned in a way that could not be explained by the gravitational influence of the known planets. According to their research, the gravitational pull of a massive, unseen object could be the cause of this strange alignment. This was no small discovery. In fact, the probability that these objects' orbits were all aligned by chance was extremely low, less than 1%. The implications were clear: something massive, and previously undetected, was lurking in the farthest reaches of the solar system. This object, according to their calculations, was likely a planet with a mass roughly 10 times that of Earth, orbiting the Sun from a distance of 400 to 1,500 astronomical units, AU. For perspective, Earth orbits the Sun at $1, and Neptune, the farthest known planet, orbits the Sun at an average distance of about $30. If Planet 9 exists, it would be far out of the reach of our current telescopes, making it incredibly difficult to detect. But how could such a massive planet remain hidden for so long? The answer lies in the sheer distance of its orbit. While Earth takes just 365 days to complete one orbit of the Sun, Planet 9 would take an astonishing 10,000 to 20,000 years to make a single orbit. This means that for most of the time, the planet would be so far from the Sun that its faint light would be nearly impossible to detect. Furthermore, it is believed that Planet 9 would be very dim, emitting little radiation, mostly in the infrared spectrum. This would make it even harder to spot using traditional telescopes, which are designed to capture visible light. Even if we could observe it, the planet would likely appear faint and cold, with an estimated temperature of around 47 Kelvin, minus 226 degrees Celsius, or minus 377 degrees Fahrenheit. This is just a little warmer than the background temperature of space itself, which is roughly 2.7 K. To make things even more difficult, Planet 9's orbit is likely to be highly inclined and eccentric, meaning that it doesn't follow the same flat plane as the other planets in the solar system. This would make it difficult to locate using telescopes that are primarily focused on the ecliptic plane, where most of the solar system's objects reside. So, what does this mean for our search? While the task of finding Planet 9 might seem daunting, astronomers are not giving up. In fact, they are ramping up their efforts, and new technologies and telescopes are poised to take the search to the next level. One of the most promising tools in this pursuit is the Vera C. Rubin Observatory, a powerful new telescope currently under construction in Chile. Once operational, this observatory will conduct a comprehensive sky survey, mapping the entire sky in visible and infrared wavelengths. The data it collects will be invaluable in identifying distant objects like Planet 9, and astronomers are hopeful that this telescope will be able to spot the faint, distant planet. In addition to ground-based observatories, space telescopes like the James Webb Space Telescope, JWST, could also play a crucial role. The JWST, which is set to begin its scientific observations soon, is capable of detecting infrared radiation and could provide the necessary observations to confirm or refute the existence of Planet 9. While the JWST is not specifically designed to search for distant planets, its unparalleled sensitivity and resolution make it an ideal tool for observing faint objects in the outer solar system. In fact, astronomers are already making plans to use JWST to search for Planet 9 once the telescope begins its operations in earnest. But the discovery of Planet 9 would not just be a triumph of technology, it would also raise some profound questions about the formation and evolution of our solar system. If Planet 9 exists, it could challenge our current understanding of planetary formation. According to the most widely accepted models, planets form from the gas and dust that surrounds a young star in a protoplanetary disk. In the case of the gas giants like Jupiter, Saturn, Uranus, and Neptune, they likely formed closer to the Sun, before migrating to their current positions. But if Planet 9 formed in a similar way, how could it have ended up so far out in the solar system? Several theories have been proposed to explain how Planet 9 might have ended up in its distant orbit. One possibility is that it formed closer to the Sun, like the other gas giants, but was then pushed outward due to gravitational interactions with other objects or planets in the early solar system. This could have caused it to be ejected into an eccentric, highly inclined orbit. Another theory suggests that Planet 9 could have been captured from a passing star in the early days of the solar system, a scenario known as the rogue planet hypothesis. If a nearby star passed close enough to the Sun during the solar system's formation, it might have gravitationally captured Planet 9, sending it into its current orbit. Yet another possibility is that Planet 9 formed in the outer reaches of the solar system, in a region where the gas and dust would have been less dense. This theory, known as the outer formation hypothesis, suggests that the planet could have formed from the material present in the primordial solar nebula but in a much more distant location than the gas giants. Over time, gravitational interactions with the other planets could have pushed it into its current eccentric orbit. Regardless of how it formed, the discovery of Planet 9 would force us to rethink the processes that govern planetary formation and the evolution of our solar system. While the hunt for Planet 9 is far from over, the excitement around this potential discovery is palpable. Each new observation brings us closer to uncovering the secrets of the distant reaches of our solar system. And even if Planet 9 is never found, the search itself has already expanded our understanding of the solar system in ways we never expected. The future of planetary exploration is bright, and who knows, perhaps the next great discovery is just waiting to be made. As we continue our search for Planet 9, one thing is certain: the universe is full of mysteries, and with each new discovery, we take one step closer to unraveling them. Whether we find Planet 9 or not, the journey of exploration will continue to captivate and inspire us, offering new insights into the nature of our solar system and our place in the cosmos. So, the next time you look up at the night sky, remember that there could be something out there, just beyond the reach of our telescopes, waiting to be discovered. And who knows? Maybe we're on the verge of a new chapter in our understanding of the universe.